welcome back to our channel Chemistry with RK, and the time has come now. The students, those who are appearing, from past 4 to 5 days for JEE mains January attempt of 2024. Hope you're all doing well. And then, today's discussion I have taken 30th paper. Okay, so 30th, just 2 days back, the students have written JEE mains, that is the morning shift paper. I am going to explain. So in this video we are going to see the question paper and then deep analysis of that question paper. And then one of the good thing I have observed is the students, those who have subscribed to my channel, those who have following my channel from the beginning, I hope they have got some idea, with this very short span of time, whatever videos I have uploaded, the students have got most of the questions in different sessions from the questions which I have discussed in my videos. Okay, I feel very happy for that, and I hope students have taken benefit of that. Yes, I have been continuously telling, please, I am going to show those questions in my videos, and then I'm going to correlate this particular question paper with my previous lectures. So in my previous videos, I have given most of this model questions, and some of the questions have been directly given in this particular different sessions of this January attempt. So that is the very happiest thing. So in this video, we are going to see the detailed explanation of those questions which are asked in a particular session. And in addition to that, I am going to give some additional information. Suppose, let's say a question is asked in this particular attempt, and then what are the other possibilities of getting the same question in a different way? Or I'll try to give you some more additional data for the given options also. So please, I request you to subscribe to my channel and don't forget to click on the bell icon to get the regular updates. So with this particular, within this 4 months, whatever videos I have uploaded, I can say proudly that most of the question in this January attempt has been selected from the questions I already explained you in my previous videos. Okay, without skipping the video, please do watch it completely till end and try to separate the data I'm going to give you in this video. Okay, so yes, in this we are going to see the detailed explanation and then the question paper analysis and then the expected questions. So let us start with our first question, that is, yes, here we have a question related to organic chemistry, which is a very well-known reaction. So if you observe carefully, they have given here, this is actually called as benzoyl chloride. Yes, this is called as benzoyl chloride. And now उस benzoyl chloride को hydrogen palladium BaSO4 के presence में किए तो, so what exactly we are going to get here is, we are going to get benzaldehyde as the major product. Yes, and now this particular reaction has a very well-known name reaction called as Rosenman reduction. Yes, so among the 4 options, we need to select the Rosenman reduction. So simply, this is the question directly taken from NCERT. Yes, so not only this question, most of the questions coming in the different sessions of this January attempt is directly taken from the NCERT textbook. So please do refer that NCERT textbook other than referring any other materials, okay, unnecessarily. Or else please do watch my previous videos so that you can able to collect more information which is related to the NCERT textbook and beyond that. Okay, right. So as of now, for this question, actually the answer is Rosenman reduction. As far as this particular question is concerned, we can stop with the Rosenman reduction. Yes, it's simply benzoyl chloride converting to benzaldehyde by using hydrogen in the presence of the catalyst we are going to use is palladium BaSO4. Okay, which is actually called as Lindlar's catalyst. Yes, the same Lindlar's catalyst we can able to use in the partial hydrogenation of alkynes, which gives us cis alkenes as the major product, which I have detailedly explained in my previous lectures. Okay, please keeping that point in mind, let us just check the remaining 3 options. What could be the Itard reaction? Yes, this is also a very well-known reaction in the organic chemistry, which is nothing but conversion of toluene. Generally, the conversion of toluene. Yes, we are going to take toluene, which is nothing but methyl benzene. Yes, this methyl benzene, we are going to take chromyl chloride, which is CrO2Cl2, and we are going to take carbon disulfide also in the presence of small amount of acid. Yes, in this particular reaction we are going to get the same product, benzaldehyde we are going to get. But the question we have here is benzoyl chloride reacting with palladium BaSO4. It's not the Itard reaction. Let us see the Stefan's reduction, which is nothing but generally the conversion of alkyl or aryl cyanides. So which is nothing but C triple bond N. Yes, this type of functional groups in the presence of stannous chloride, in the presence of HCl. Yes, it is finally we are going to get aldehyde as the major product. The intermediate we are going to get in this particular reaction is aldimine is the intermediate we are going to get in this what do you say that? Stefan's reduction. So obviously this is also not our answer. And then next if we move on to the next one, that is Wolff-Kishner reduction. Yes, we are going to see Wolff-Kishner reduction is also simple, like conversion of aldehydes and ketones into alkanes by using hydrazine, that is NH2NH2 in the presence of alcoholic KOH. So just we can take acetone. Yes, we can take acetone, and then by using NH2, that is hydrazine. Yes, and then in the first step we use hydrazine, and then by using alcoholic KOH we are going to get directly propane is the major product. So with this we can understand the suitable answer for the given question is Rosenman reduction. Hope you understood. So for the given question I have given you the answer. In addition to that I have given the additional information. Suppose let's say in this particular exam they have asked about Rosenman reduction. Maybe in the coming second attempt of the JEE mains or the upcoming NEET exams they may ask what is Itard reaction or Stefan's reduction or Wolff-Kishner reduction. In addition to this we have so many organic name reactions. On this organic name reactions also I am going to make a separate video where the things are going to be very simpler for the students to memorize and then to go to the exam hall and then directly choosing the option according to the given question. Okay, yeah, let us continue. That is the second question we have here is find the final product for the below reaction. Yes, we have a bromobenzene. First they are reacting with magnesium diether and then followed by reacting with carbon dioxide with acid, and then ammonia upon heating, and then finally bromine. This is actually called as Hoffman bromamide reaction, where we prepare only the primary amines in this particular reaction. Okay, let us just go step by step. That is the initial compound we have, that is going to be the bromobenzene. Yes, what is actually bromobenzene is going to give us when it reacts with magnesium with dry ether. Yes, this is also a very famous reagent we are going to get here is a phenyl magnesium bromide. Yes, which is nothing but Grignard reagent. Yes, Grignard reagent is the major product. And now what happens is when we react this Grignard reagent with carbon dioxide or any C double bond O containing groups, finally what we are going to get is the benzoic acid. Yes, benzoic acid we are going to get by reacting phenyl magnesium bromide with CO2. Yes, so what happening exactly is generally we know that CO2 is a linear molecule. Yes, when we are going to react this with phenyl magnesium bromide, okay, this phenyl is going to attack here and then this oxygen comes out as O minus. So we are going to get that is COMgBr, and then we are going to get a phenyl ring to the carbon. And then further this upon reacting with the acid we are going to get benzoic acid, where this MgBr will come out and then hydrogen is going to go on to that oxygen, giving out this benzoic acid. Hope you understood. And now the reaction is not yet completed actually. This particular benzoic acid they have reacted with ammonia. Yes, this is actually a acid, and now generally NH3 behaves as a base. Acid reacts with base to give a salt. So what type of salt we are going to get here? that is ammonium salt of the benzoic acid we are going to get. Yes, this is called as ammonium benzoate, and then this upon further heating it loses H2O, that is, yes, we are going to get benzamide as the major product here. Yes, that is CONH2. Yes, this is actually one of the products. And then finally this reaction is very important, which is called as Hoffman bromamide reaction. Okay, Hoffman bromamide reaction. Yes, this is very famous in the preparation of primary amines, particularly Hoffman bromamide reaction. So what is that we are going to get in the final step here is aniline. Yes, so what happens in the Hoffman bromamide reaction? Conversion of amide to amine with one carbon less, very important. Yes, so finally we have got our option, that is aniline is the major product. Actually in this particular session related to aniline we have got almost 2 questions, okay, which we are going to get soon. So hope you understood. Yes, it is a clear cut answer for this particular question is aniline. Yes, it is very beautiful conversion. Hope you understood. So whatever data I am trying to give you in this particular conversions and then related to the question, so please you try to write down separately, so that at least it will be helpful for your upcoming 2024 April attempt at least. Okay, so please and now very important, these two are also the products but not the final product here. These two are also intermediate products. Okay, suppose let's say if they ask us to stop the reaction till the second step itself, yes, obviously we have to select the benzoic acid as the major product. अगर समझो question को इधर रोक दिए तो, so we are going to get the second that is benzamide as a major product. Okay, and now this is obviously not the any of the products in this reaction. So yes, let us just continue with this next question. Yeah, here there is a question, which of the following has allylic halogen? Yes, this is such an easy question. Normally, every teacher will teach you this particular terminology in the IUPAC nomenclature itself, in the GOC1 of first year, even in the alkyl halides of the second year. Allylic halogen or allylic, actually what type of carbon is called as allylic carbon? A sp3 hybridized carbon which is directly attached to sp2 hybridized carbon of a carbon-carbon double bond is said to be allylic carbon. And to such type of allylic carbon, the halogen attached is called as allylic halogen. Yes, keeping that point in mind, just I am trying to give you, yes, as I told you, this is suppose let's say sp3 hybridized carbon. Okay, this is, yes, we can say this is sp3 hybridized carbon which is directly attached to sp2 hybridized carbon of a carbon-carbon double bond. Yes, this particular carbon is now called as allylic carbon अगर इस कार्बन को कुछ halogen है, so obviously we can call it as allylic halogen. Yes, so simply let us just try to correlate. Yes, if you observe this particular carbon is sp3 hybridized carbon, उसका directly attached carbon is again sp3, so obviously option A is not our answer. And then next, if we move to the second option, yes, the carbon, this is actually sp3 hybridized carbon, again uska directly attached carbon on both sides is again sp3, so again delete that option also. And then next, if you move to this, yes, here we have this particular carbon here sp3, and now directly attached carbon is sp2. Yes, and then next, this is a carbon-carbon multiple bond. Yes, obviously the answer for this question is going to be the third one, which is a very basic foundation level question. Okay, chalo, such type of questions are more in the different sessions of this January 2024 attempt. So generally students feel that yes, we are going to write IIT, so just the exam is very tough. Then generally the students will be in this type of mentality, this type of thought process they will be running in their mind. But generally, by looking at these different attempts paper of this January, or not only this year, from the last 2 years, they are directly giving questions from the NCERT, and then students are later they are feeling, so better, it would have been better if we would have given some extra time for the preparation. So please, I request my students, those who are watching my video, please, I request you to do some extra preparation before going into the exam hall, so that you will not feel this type of regrets. Okay, I can say 100% that is, yes, even for the upcoming April attempt, the question paper is going to be very easy. Yes, one thing we can understand clearly, few questions, maybe 5 to 8 questions, they are going to give very tough. Generally those questions can be solved by the students, those who are very vigorously preparing for the IIT mains and advance. And then rest of almost 17 to 18 questions, the students, most of the 90% of the students can able to do. But please, you have to spend some time for your IIT preparation and all. Okay, yes, let us just now this particular the last option, if you see here, we can't exactly give allylic terminology here. We can say this is actually called as secondary alkyl halide, since this halogen is attached to a secondary carbon. Why it is secondary carbon? This carbon is directly attached to 2 other carbons. So these 2 are primary carbons and the middle one is secondary carbon. So secondary alkyl halide. Yes. Yeah. Next, let us move to the next question. Yes, this question I have explained in my aromaticity video. Please do watch it. In that particular video, directly I have taken these examples. Yes. The stability, I have compared stabilities, I have compared dipole moments, I have compared acidic strengths, I have compared the aromatic natures, non-aromatic natures, and then everything, stabilities and all. So please, those who are new to the channel, those who are watching my video for the first time, please do watch all my videos from the beginning. My students are continuously texting the messages, sir, this very short span of time of almost your 70 videos have helped us a lot in our IIT preparation. Most of the questions, may be directly related to the concept. The questions have come from my previous videos. So please, I request you to watch the videos without skipping. Yes, it is going to help you. It's not going to help me, it is going to help you. At least for your April attempt, you will make sure all the concepts will be clear, so that you can crack IIT. Yes, don't keep in mind, almost I have wasted 2 years of time, and then within this 1 or 2 months, can I be able to get into IITs? Yes, it is possible. So please do follow, please do focus on your preparation. Okay, right. So now the question is, which of the following compound or ion is most stable? So one thing we can understand here, the ion or compound which is going to be stable is the one which is aromatic. Yes, the one which is aromatic is going to be more stable. Yes, and now keeping that point in mind, here we can have 4 pi electrons. 4 pi electrons hai, obviously not aromatic rules. Aromatic rules ke liye what are the rules it need to follow? 4n plus 2 pi electrons, which is nothing but Haeckel's rule. All the central atoms need to undergo sp2 hybridized, and then it need to follow the condition of planarity. And the next condition is the molecule must follow conjugation. We can have alternate double bonds or double single, positive charge, double single, negative charge, or double single. A lone pair is also possible. In such cases, we can expect conjugation. Yeah, these 4 rules a molecule is going to follow. It is said to be aromatic. Yes, here the question is, which of the following compound is more stable? Okay, yes, I told you the one with the aromatic nature is going to be more stable. Yes, you please try to check. Obviously, not the first option, not the second option. Here we don't have any pi electrons actually, and then even all the carbons are also not sp2. Yes, if you look at the third option, we can see 2 pi electrons are there, and then these 2 carbons are sp2 hybridized, and then even the carbocationic carbon is also sp2 hybridized. For more explanation, please do watch my aromaticity video, please. Okay, and then all of them are sp2. Yes, it is going to be planar, and then there is a conjugation also, double, single, and then positive. Yes, this is our option, no doubt in that. Yes, and then next, if you move to the fourth one, just if you check it, yes, this is not our option obviously, but 4 pi electrons are there. The negative charge need to be considered as 2 pi electrons. I have explained this particular case in my video aromaticity. Please do watch that video. Okay. So option C is the aromatic and then it is going to be more stable. Yes. Which of the following set contains both diamagnetic ions? What do you mean by diamagnetic actually? The ion or atom need not to have any unpaired electrons. Should not have any unpaired electrons. Okay. Yes, so for that what we need to do is we need to write their ionic electronic configurations actually. Okay, so if you look at this first one, that is, let us write down the electronic configuration of nickel whose atomic number is 28, that is nothing but argon 4s2 3d8 actually. And then next we need to remove 2 electrons, that too we need to remove from the outermost shell of 4s actually. Yes, by after removing those 2 electrons we are having D8 configuration where we are going to get, okay, so 2 unpaired electrons are there. Obviously we can just delete that option. Just by checking the first Ni+2 we can avoid it, we can just delete it. Okay, and then next let us just go with Cu. The atomic number is 29 whose electronic configuration is 4s1 3d10. So now since we have +1 charge, so we need to remove 1 electron. So where we are going to have D10 configuration without any unpaired electrons. So D10 is all the electrons are paired. So obviously this could be the answer. Please, we need to check the next one also, that is zinc. So zinc atomic number hai 30. Yes, and then our electronic configuration is argon 4s2 3d10. And now what we need to do, zinc +2 has, so we need to remove 2 electrons from 4s. Again it is also going to give us D10 configuration without any unpaired electrons. Yes, we have got our answer. Obviously we can avoid just writing the, first actually these are the F block ions, right? F block element ions. So better you just try to check first the very familiar elements of D block. So once after checking these D block ions, if you didn't get your answer, then we can able to go to F block. Directly if we try to search this particular F block ions, then their atomic numbers, configurations are quite complicated, so compared to D block. So it is better first to check the familiar ions. So we have got our answer within this Cu plus and Zn plus 2. Okay, right. And then with this, see, the same way they can ask another type of question. Here they have asked diamagnetic ions, but we can also have paramagnetic ions. So what are first of all paramagnetic ions? So the one which has unpaired electrons. Here diamagnetic is no unpaired electrons, paramagnetic is having unpaired electrons. Okay, so please keep that point in mind. And then next let us move to the next question. Yes, consider the following sequence of reactions, that is aniline reacting with some reagent A gives benzene diazonium chloride, upon reacting with B giving us orange red dye. This is also directly from NCERT textbook. Okay, yes, please my dear students, please I request you to follow the standard NCERT textbook, or else you please watch my videos. Yes, I can proudly say that. So whatever information I am giving you through my videos is completely related to NCERT, and then beyond that NCERT, not below to that. Okay, yes, once if you start watching all my videos, you will get to know almost these January attempt papers, different session papers, I can say most of the questions you can solve very easily. Chalo, let us just come back to this question. They have given aniline. Yes, just few minutes back we have solved a question, that is bromobenzene reacts with magnesium diether and then so on, right? There are 4 conversions actually. Finally we have ended up with Hoffman bromamide reaction gives aniline, right? Yes, that aniline we can carry out the further reaction with NaNO2HCl. That is actually this reaction called as diazotization. So yes, I am just giving you the reaction here. Aniline which is benzene ke upar NH2, which is going to react with NaNO2HCl, yes, at 0 degree centigrade to 5 degree centigrade, giving us benzene diazonium chloride. Okay, yes, this is very well known famous reaction called as diazotization. Yeah, this is also one of the famous name reaction of aniline, yes, and now this particular NaNO2 plus HCl undergoes in situ reaction to give us HNO2. Okay, we can't use HNO2 which is already directly prepared. Okay, so here instead of using HNO2 we need to take NaNO2 HCl, so that HNO2 will be produced within the reaction, which is called as in situ reaction. Okay, right, and now so this benzene diazonium chloride is going to give us orange red dye when it reacts with here the combinations are there with these two actually. So with phenol it is going to give orange red dye, and with aniline it is going to give us yellow colored dye, but in the question they are asking orange red dye, so we need to go with this phenol. अगर समझो इधर ऑरेंज रेड डाई के प्लेस में येलो डाई दिया, and then we need to go with aniline. It could be another question which can be expected in the next upcoming sessions. Okay, so please you try to let me just try to give you the reaction here. So when we react this with phenol, actually phenol is, yes, this one, that is benzene with OH, and now what happens here is इधर ए जो Cl है इधर जो है हाइड्रोजन के साथ चले जाएगा, and then we are going to get yes, we are going to get azo group will be produced. Okay, yes, this is our orange red dye, yes, very important. So with phenol we are going to get the orange red dye, so undoubtedly we can go with NaNO2 HCl and then phenol. Yes, this is a very beautiful question. Yeah, let us just move to the next question, that is we have correct structure for the IUPAC name 3-methyl pent 2-enol. Okay, yes, obviously here the last secondary suffix defines about the functional group. In all the four we can see aldehyde functional group only. Okay, and then at the second position we need to have a double bond. So always we know that according to IUPAC the least number must be given for the major functional group, that is aldehyde. तो इस कार्बन को 1 लेना है, तो अभी next कार्बन के पास, second कार्बन के पास we have a double bond which is not there in the first option. Yes, just remove it. And the next second option is the possible one. Just let us see if this carbon is the first one, this is the second one, third, fourth, fifth. Okay, just let us see there is second carbon पे double bond भी है और third position पे yes we have methyl also. Undoubtedly yes we can go with this. See, this type of questions are very easy. In fact this is actually student need to take the advantage of that question. Okay, because the name and the structure will be both given in the question itself. Just we need to cross check, we need to go with the elimination method. अगर ये देखो second position पे double bond नहीं है तो I have deleted that particular option. Even in this one also second position पे नहीं है, इसको भी delete कर सकता है. And then now we have a second carbon पे double bond है but third carbon पे methyl नहीं है. Yes, just remove it. Yes. So likewise we need to go with the cross checking. This is very easy one. Yeah, please now you try to name the remaining. So we have got our answer, but you try to do the remaining also for your practice. And the next, the group number of anium. Yes, according to the the modern periodic table, we need to give the number for anium, which is actually an means 1 and then an means 1, anium means 1. Yeah, the atomic number for this particular the element we have in the question is 111. Yes, if you observe the P block, that is we have totally of 6 groups in the P block, and if you observe the last element of the 18th group, which is actually oganessan, whose atomic number is 118. So you just come back to that, which is going to be 117 and then 116 and then 115 and then 114 and then we have 113, and if you continue we have 112 and then 111. And if you observe in the P block, we have 13th, 14th, 15th. Yes, here starts with the boron family 13th group hai. Before that we have a 12th group and then we have 11th group. Yes, we have 111 atomic number belongs to the 11th group of the periodic table. Yes, this is also simple question related to the periodic table which most of the students can able to solve. Okay, yes, and then next let us go for the next question, that is choose the correct option. Yes, here we have few molecules and then their shapes. Okay, so let us just go to our BRFI. So what is the group number? So it's very easy to find out the number of bond pairs and then lone pairs just by having its group number actually. So bromine belongs to 7th A group, so it has 7 valence electrons. So 4, 5, 6, 7. Out of these 7 valence electrons, 5 are bonded to the fluorine. So with 5 bond pairs actually. And then we have one extra lone pair with the bromine. So where we can conclude that in BRFI, bromine has 5 bond pairs with 1 lone pair. Altogether, the sum of bond pairs and lone pairs gives us electron pairs, which is going to give us sp3d2. 6 electron pairs hai, ek s 3 p's and then we have 2 Ds, altogether 6 electron pairs. And now one of the very important points here we need to understand is, with 5 bond pairs and 1 lone pair, what could be the possible shape or geometry of the molecule? Square pyramidal. Yes, square pyramidal is the expected geometry. So just if you observe BRFI co, yes, we have square pyramidal. And then next if we move to our what do you say that is water. Yes, in the water we can say oxygen is the central atom whose group number is 6th A. So it has 6 valence electrons, out of which 2 will be bonded for the 2 hydrogens. So 2 bond pairs are there and then 2 lone pairs are there, altogether 4 electron pairs are there. So the hybridization is going to be sp3 and the shape of water is going to be angular or bent. So it is going to be 2 bond pairs and 2 lone pairs ke corresponding mein we are going to get either bent or angular. Just if you observe what is the option they have given. Yes, water ko bent diya hai. And then next if you go back to our ClF3, yes, simply this is a very well known compound. Here we can indirectly make a point, that is trihalides of halogens generally undergoes sp3d hybridization with 3 bond pairs and 2 lone pairs actually. Okay, so now the group number of chlorine is 7th A, so it will have 7 valence electrons, out of which 3 will be bonded for fluorines and then 2 will be the lone pair. So 3 bond pairs and then 2 lone pairs, altogether 5 electron pairs. The hybridization is going to be sp3d, which is going to have T shape. Okay, and then next if you observe where is the option? Yes, we have. And then SF4, with this 3 we can get our answer. Just let me give you one more example, that is SF4. Sulfur is the central atom whose group number is 6th A, whereas the 4 fluorines will be bonding to this which is going to form 4 bond pairs and then 1 lone pair, altogether 5 electron pairs, which is going to give us sp3d hybridization with a seesaw shape or distorted tetrahedral. Also we say seesaw or distorted tetrahedral. Okay, right. With this we can just get our answer, that is seesaw. So that is A co 4th option, A4 and then B3, A4, B3 and then C2. Yes, we can have the first option. So with this we can conclude that our first option is the suitable answer. But not only these particular molecules, we can able to take any molecule and following by the same rule we can able to get its corresponding hybridization and also shapes for the molecules. Okay, but one thing, the group numbers for those particular central atoms need to be known. So not only in this question, in all sessions, in every session, in every different types of different kinds of exams, generally the students write after completing their 12th class, they are going to get 110% at least one question directly from the VSCPR theory. Yes, actually this concept is related to VSCPR theory. I always used to say that please go to the exam hall with that particular VSCPR theory table. Okay, so please do refer that VSCPR theory table. If you can memorize that particular VSCPR theory table, so which relates to the shapes and what do you say, that electron pairs and bond pairs and lone pairs and all, you are going to get a maximum questions you can able to solve by using that VSCPR theory. Okay, right. And then next let's continue with our next question, that is, this particular question is directly from one of my shorts I have uploaded in my channel. Okay, yes, this particular question is a very well known question. We are going to get a higher alkyne from a lower alkyne by undergoing or reacting with sodium, which is going to give us sodium acetylide. So please, if you are new to the channel, please do watch all my videos so that you will get most of the benefit out of it. Okay, so don't neglect it, please take it seriously, and then try to follow the channel carefully so that at least you will get maximum marks at least in our April attempt. Okay, chalo. Okay, let us see what happens here. Here we have a propyne and we have an acidic proton. When it reacts with sodium, we are going to get sodium acetylide. Okay, so this is actually sp hybridized carbon, and then A jo hydrogen H plus hai, yes, it is going to have Na plus generally. Yes, it is going to replace. So sodium acetylide we are going to go. Obviously not our A and D are eliminated. Okay, yes, this is how you need to do the organic questions, which is very easy. Okay, generally, yes, I always tell my students, in my regular classroom teaching program, please, go with the elimination, don't get what do you say, that stuck, don't get nervous, don't get confused when you look at a question. You please try to observe, you try to understand the question. So with your 2 years of your NEET and IIT training, you will obviously get at least 1% idea. But please, you have to be strong, you should not get panic in the exam hall. Okay, which is a very easy one. Here we have sodium acetylides. And now what we are going to get here is, see, this particular part we have in our parent alkyne itself. So we have 3 extra carbons. With 3 extra carbons containing alkyl halide, yes, undoubtedly we can go with the option C. Clear? Which is a very easy one. Please, my dear students, please, at least, as of now, if you fail to attempt, if you fail to write your exam properly, please just don't lose hopes on your IIT exam. Please wait for your next upcoming April attempt. Till that, I'll be uploading more videos on these, even the question papers, even from the concept point of view. So please do watch all the videos without skipping. Yes, it is going to give you more score in your chemistry April attempt. Okay. Yes, such an easy question. Agar samjho, if we use this particular alkyl halide, what is that we are going to get? Yes, this particular group is going to be present as it is, but we are going to get only the 2 carbons only. But we have 3 carbons. So which is the suitable one? 3 carbons containing alkyl halide need to be taken. That's it. Yes, if you ask me to give the reaction, that is CH3, C triple bond, C, and then let me just H we have, and then isko Na, that is sodium ke saath react karne se we are going to get C triple bond C and then Na. And now once if we react this with CH3 and then CH2 and then CH2 and then Cl, yes, remove this Cl, NaCl, and then attach this entire group. Okay, so yes, we are going to get C and then CH2, CH2 and then CH3. Okay, hex 2 ine is the product, you can see clearly. Okay, right, this is an easy one. Next, if you look at match the following and select the correct option. Yes, this is related to the previous question. I told you to write down the ion configuration. For Cu plus and Zn plus 2, I have solved it, right? And now with the help of those questions, you please, you try to solve this question, you are going to get an answer very easily. That is Mn plus 2. Mn ka atomic number hai 25, that is argon 4s2, 3d5 actually, okay? So yes, we are going to get Mn configuration is 25, so obviously we are going to get 4s2, 3d5. And now since we have Mn plus 2, so we need to remove this 4s0, 3d5, so 4s0, 3d5, yes, we have got our first one. And then vanadium plus, okay, let us just go for vanadium, scandium, titanium, vanadium. The atomic number is 23, whose configuration is going to be argon 4s2, 3d3. And now we have vanadium plus actually. So where we need to remove only one of the electron from 4s, which is going to give us 4s1, 3d3. Yes, so for B it is 1. A ko 2 आना है and then B को 1. Yes, A को 2, B को 1. So obviously option 1 and option 2 are deleted. And then option 3 and option 4 के अंदर हमारा आंसर है. Let us just go with the Cr plus. So chromium, its atomic number is 24, whose configuration is, anomalous configuration is there for chromium and copper. We know one of the electron we need to remove since they are asking for Cr plus. And then for Cr plus 4s, yes, for Cr plus also we have got a second option itself, that is second one. So which is the suitable one? This is also not our option. The third one is our answer. Any doubts? Which is, see, if you observe carefully, I have been continuously deleting the options which are not suitable for the given question. Okay, I am just eliminating the options. Just if you observe, by what do you say, that by getting a particular electronic configuration for Mn plus 2, we have deleted just A and B ko delete kar sakte. So answer must be among C and D only. Okay, let us move to the next question, that is, yes, what happens to the freezing point of benzene when a small amount of naphthalene is added to benzene? Naphthalene is added to benzene. Yes, this is also direct question from NCERT of the solutions chapter of the second year. Yes, what happens to the freezing point? So when we add a non-volatile solute to a pure volatile solvent, always its freezing point is going to be decreased. That is nothing but depression in freezing point. Just we have to know the term depression means decrease. Always when we add naphthalene to benzene, its freezing point is going to decrease. Yes, simple point from NCERT. Not only this, you please try to understand, whenever we add a non-volatile solute to a pure volatile solvent, always the freezing point will decrease. And what happens to its boiling point? It is going to increase. Elevation in boiling point, depression in freezing point. So whenever we add pure volatile solvent को non-volatile solute add करने से उसका boiling point increase होगा, उसका freezing point decrease होगा. Okay. Yeah. Next, let's move on to our next question. That is, yes. Okay. We have two statements actually regarding hydrogen atom. And then they are asking, whether both the statements are correct or any one of the statements are correct and all. First of all, let us see the statement 1. For hydrogen atom, 3p and 3d are degenerate. Yes, this is beautiful. Yes, if you don't forget a point we have in the atomic structure for hydrogen atom, actually the energy of the subshell depends upon the principal quantum number, not on the azimuthal quantum number. So what does it mean actually? For hydrogen we know only we have a 1s actually, and then 1s ko energy will be less compared to 2s, and then 2p. If we try to compare the energy for hydrogen among 2s and 2p, they are going to be equal, which are nothing but these two are degenerate with respect to each other. And then similarly 3s is equals to 3p is equals to 3d. These three are also degenerate with respect to each other. Yeah, that is what we can understand from the question. So they have 3p and 3d are degenerate. Yes, 100% 3p and 3d are degenerate. For hydrogen atom, You please make a point of this. For hydrogen atom, the energy depends upon the principal quantum number. Okay, since the principal quantum number is same, obviously they have equal energies. And then degenerate orbitals have same energy. Yes, this statement is beautiful. With this statement only we can able to get our first answer actually. Okay, yes, so we can conclude that degenerate orbitals have same energy. The statement first one is also correct actually, second one is also correct. So both the statements are correct. So we can go with the first option itself. Yes. So these are the questions I have selected from 30th January. So soon, maybe tomorrow, I'm going to come up with some other session ka paper, and then I'm going to give you the detailed explanation. Hope you like this video. First of all, please, if you're new to the channel, I request you to subscribe, and then don't forget to click on the bell icon to get the regular updates. Please spread my channel. I always would like to invite all your suggestions, advices. I want all your support to carry this particular journey. So thank you so much. See you soon with our upcoming video.